Good morning, children. Sairam. Children, we have completed the chapter Structure of Atom. I have told you in the previous presentation that today we'll be discussing some of the questions of the NCERT book. Now, I hope you all are able to see what is written on the screen. I'll be discussing this question today. The question is, from the following set of quantum numbers, state which are possible. Explain why the others are not possible. That means you have to tell which quantum numbers are possible from the above set. Now, if we look at the first set of quantum numbers, this is n. The n value is 0. That means the principal quantum number is 0. Azimuthal quantum number is also given to be 0. Magnetic quantum number is 0 and this spin quantum number is half. Now tell me whether this shell, this address of electron is possible. No, it is not possible. Why? Because the value of this n, the principal quantum number, it cannot be 0. It will either be 1, 2 or 3 or 4. It will be some integer. It cannot be 0. So, you can say that the first set of quantum numbers, this first set of quantum numbers is not possible because the value of n cannot be 0. Now coming to the second sort of quantum number where n is 1, L is 0, M is 0, Ms is minus 1. It is equal to minus 1. Now tell me, when the value of n is 1, what are the possible values of L? It will be 0 and 1. And here the value of L is given 0. That means we are talking about only this subshell. We are not talking about this subshell. Now, when the value of L is 0, the value of ML will also be 0. So, we are talking about only this. And MS is minus half. So, this set of quantum numbers is possible. Now, coming to the third set of quantum number. In the third set of quantum number, the value of n is 1. L is 1. L can be 0 and 1. Here the value of L is 1. Now when L is 1, ML is from minus L to plus L. That will be minus 1, 0, plus 1. But here we are not talking about plus 1 and minus 1. We are talking only about the 0. And the value of MS is plus half. Now see, the set of quantum number is not possible because L cannot be equal to 1. That means when the value of n is 1, then L is equal to what? It is up to n minus 1. That means L will be 0 only. As I have told you when we were discussing the quantum numbers, when n is 1, L will be only 0. When n is 2, L will be 0 and 1. So, like this we have to do. Number 4, when the value of the fourth set of quantum number is when the value of n is 1, L is 0. When n is 1, L can be 0 or not? Yes, it can be 0. ML is plus 1. Is it possible? L is 0, ML is plus 1. No, it is not possible. When the value of principal quantum number is 1, azimuthal quantum number can be 0 only. It cannot be 1. So, magnetic quantum number will also be 0. It cannot be plus 1. So, this fourth set of quantum number is not possible. Now, coming to the fifth set of quantum number, here when the value of n is 3, L is also 3. Is it possible? No, because L is from 0 to n minus 1. L cannot be 3 here. It can be 2 only. So, this is also not possible. Now, coming to the fourth set of quantum number, n is 3. L is 1. Can L be 1 when n is 3? Yes, it can be 0, 1 and 2. Now, this ML is 0. ML can be 0. MS can be plus half. So, you can say that the sixth set of quantum number is possible. Now, again looking at the question, which all sets are possible and which all are not possible. See, the first set of quantum number n is 0, L is 0, ML is 0 and MS is plus half. When L is 0, N is 0, N 0 is not possible. So, it is not possible. Coming to the second set of quantum number. The second set of quantum number n is 1, L is 0, 0 minus half is possible. N1, L also 1, not possible. Why? When n is 1, L should be 0 only. Now coming to the fourth set of quantum number, n is 1 and L is 0, ML is plus 1. Now when L is 0, ML cannot be plus 1. So not possible. Now coming to the fifth set of quantum number, n is 3, L is also 3. Azimuthal quantum number cannot be 3 when principal quantum number is 3. It can be only up to 2. So not possible, and the sixth set of quantum number is possible. Children, I know it is difficult to understand like this here, but if you are clear with the quantum numbers, it can be understood here also. Now, this question is done. Coming to the next question. Arrange the following types of radiations in the order of increasing wavelength. We have discussed the order of increasing wavelength. The rays that are given to you here are radiation from the microwaves. You all know microwaves have very high wavelength. Amber light from the traffic signal, it is having lower than microwaves. FM waves are having highest wavelength. Cosmic rays are having the lowest wavelength, and after that comes the X-ray. So the sequence is cosmic rays, the lowest wavelength, then the X-rays, then amber rays from the traffic light, then microwaves and the FM radio waves. So this is also done. Now coming to the next question. What will be the order of energy levels 3s, 3p and 3d in case of hydrogen atom? Now see, in case of hydrogen atom, only one electron is there. So we cannot talk about these energy levels. These are having equal energies. Next question is, how many unpaired electrons are present in Z is equals to 46. That means the atomic number is 46. Now, if we see atomic number 46, then before that, the previous element in the previous row of the periodic table, the element which is present as the noble gas is your krypton, having atomic number 36. For krypton configuration, we'll write krypton inside a square bracket and write 36 electrons are there in krypton. After that, the filling takes place in 4d. So, it will be krypton, then 4d 10, 5s 0 will be the electronic configuration. Now, in d subshell, you all know 5 orbitals are there, 10 electrons are there. That means all are paired. So, there is no unpaired electron in this atom. Now see, indicate the number of unpaired electrons in phosphorus. Phosphorus, the atomic number is 15. You should write the electronic configurations for these atoms at least. For 15, what will be the electronic configuration? 1s2, 2s2, 2p6. This is for 10 electrons. For these 10 electrons, we can simply write it as neon 10. That is Ne10. This is 1s2, 2s2, 2p6. After that, the 11th electron goes to 3s orbital and 12th electron also goes to the 3s orbital. So, it becomes 3s2 and next 3 electrons will go to the 3 p orbitals. So electronic configuration simply you can say is 1s2, 2s2, 2p6, 3s2, 3p3. Children, you have to practice these electronic configurations. Now next one is your silicon. For silicon, the electronic configuration will be this way. I am writing 1s2, 2s2, 2p6. This is up to 10 electrons. Now 4 electrons are left. So 3s2, 3p2 will be the electronic configuration for silicon. 1s2, 2s2, 2p6, 3s2, 3p2. Now coming to chromium, that is having atomic number 24. Now chromium has got exceptional electronic configuration. For atomic number 24, it will be 1s2, 2s2, 2p6 for 10 electrons, then 3s2, 12, 3p6, 18. After 3p, 4s will not come. First of all, 3d will be filled. So it will be, first of all 4s will be filled. After that 3d will be filled. So 1s2, 2s2, 2p6, 3s2, 3p6, 4s should be completely filled, but it is not completely filled here. It is an exception. It will be, how many electrons left now? 5 are left. 3d, 5. Why is it so? Why is 4s1, 3d, 5? Why not 4s2, 3d, 4? It is because you all know in the d subshell there are 5 orbitals. 1, 2, 3, 4. If the configuration is suppose 4s2, 3d, 4, it will be 1, 2, 3, 4. But if it is 4s1, 3d, 5, then it becomes half filled, and you all know half filled orbital has extra stability. So it will be 4s1, 3d, 5. 5 unpaired electrons are there. Now coming to iron 26. For iron, atomic number 26, configuration will be 1s2, 2s2, 2p6, that is 10 electrons, then 3s2, 3p6, that is 18 electrons, then 4s2, 20 electrons. Then the next 6 electrons will go in 3d, that is 4s2, 3d, 6 is the electronic configuration for iron. And how many unpaired electrons will be there? See, in 3d subshell 6 electrons are there. So how will be the 6 electrons filled? 1, 2, 3, 4, 5 and the 6th one here. So how many unpaired electrons are there? 1, 2, 3 and 4 unpaired electrons are there. Now coming to krypton 36. For krypton 36, again you all can write argon, which is the previous element of the you can say inert gas family. 18 electrons are here, then 4s2, 3d, 10 and 4p6. So how many unpaired electrons are there? There is no unpaired electron. D subshell is fully filled, 10 electrons can be accommodated, and P subshell is also fully filled. Only 6 electrons can be accommodated. Now, so we have done the electronic configuration. Do write the electronic configuration of all the atoms in your notebook. Do practice like this and check how many unpaired electrons are there. Now see. Which of the following are isoelectronic species? Iso means same. Electron means number of electrons which are having same number of electrons. You all know whenever any atom gives an electron, it attains a positive charge. If it takes an electron, it attains a negative charge. Now if we see sodium, how many electrons are there in sodium generally? 11. Plus means it has given 1 electron. So the number of electrons with sodium are now 10. They are 1, 0, 10. Potassium, the atomic number is 19. 19 electrons are there, but K positive, that means 1 electron it has given, so it has 18 now. Magnesium, the atomic number is 12. 2 positive, that means 2 electrons are given. So how many left? 10. Now calcium, 2 positive, that means atomic number is 20. 2 it has given, so number of electrons are 18. Sulfur, atomic number is 16. Minus 2 is the charge, that means it has taken 2 electrons. So now it is 18 electron. Argon is already having 18. So now you can simply tell which all are isoelectronic. Potassium, calcium, sulfur and argon. K positive, Ca2 positive, S2 negative and argon are isoelectronic, and Na positive is isoelectronic to Mg2 positive. Now another question is there for you. Using S, P and D notations, describe the orbitals with following quantum numbers. When the value of N is 1, L is 0, that will be 1 S. Why? Because 0 corresponds to S orbital, 1 to P orbital, 2 for D orbital and 3 for F orbital. So it is 0, we'll write 1. 4, 3 will be 4, 3 means F. Similarly, 3, 1 will be 3, 1 means P. And 4, 2 will be 4, 2 means D. That is this. These are your orbitals. Now see the next question, you have to simply write, you have to complete symbol of atom with X and the atomic number is given as Z, atomic mass is given as A. Now the symbol of the element is given to you, that is X, atomic number Z is always written on the top and A, the atomic mass, Z is written here and the atomic mass is written on the top. So it will be element X, that is chlorine 1735. Similarly, the next one is X 92 233. 92 is uranium. Similarly, X 49. Which element has atomic number 4? Hydrogen 1, helium 2, lithium 3 and beryllium 4. So it will be beryllium. Children, do write down these questions in your notebook and practice these questions also. Now, in the next presentation, we'll be moving forward to the next chapter, the third chapter, that is periodicity in properties, the chapter related to your periodic table. Thank you, Sai Ram.